Good morning, everyone. Good afternoon. So, first of all, tell me, is my audio and my voice is audible to you? Quickly. Is my voice audible and is my audio visible? All right. That's great. Thank you so much. Now, let us start with the portion we have left in the last class. We were discussing limits and we did the sandwich theorem also, rationalization. Now, this was the sandwich theorem we have covered. These few theorems, simple theorems. And this was the last question that we have done. All right. Now, let us do this form of the limit. That is, limit x approaches to 0, log 1 plus x upon x. This will be basically 1 upon log a base e. And in general, we will see here the base of the log is a. In general, we will see that the base of the log will be e. So in that case, limit x approaches to 0, ln 1 plus x upon x is going to be 1. Got it? Ln 1 plus x upon x is going to be 1. Now, as a simple question, if I ask you, what is the answer of limit x approaches to 0, ln of 1 plus sine 3x upon x. This is what? All right. Now see, not at all a tough question. This is limit x approaches to 0. See, ln of 1 plus sine 3x. Now, if you see, now this sine 3x as x approaches to 0 is going 0. So let us create it in the denominator. Then certainly I'll have to multiply in the numerator also. And there is x in the denominator also. Now see, this ln 1 plus 0 upon 0 is 1. Now again multiply by 3x, 3x. This sine 3x by 3x, sine 0 by 0 is again 1. This x will cancel x. Answer is 3. All right. Answer is 3. Got it? Got it? Now see, here we will do a very important question. Question is, limit x approaches to 0, ln of secant x upon x squared. This is what? Very important question, and the result also better if you can remember it. So the solution is like limit x approaches to 0. I can write it minus ln cos x upon x square. That is negative sign came outside. Limit x approaches to 0, ln of. Now cos x is 1 minus 2 sine square x by 2. This is the formula for cos x, we all remember. 1 minus 2 sine square x by 2 upon x square. Got it? Now if you realize as x approaches to 0, this quantity is approaching to 0. Got it? So let us create it in the numerator and denominator. It is minus 2 sine square x by 2 minus 2 sine square x by 2. Now, this value, isn't it ln 1 plus 0 upon 0? Ln 1 plus 0 upon 0, which is this form exactly, this one. So this value is going to be 1. So what you are left with? Minus of limit x approaches to 0. You are left with minus 2 sine square x by 2 upon x square. Now see, there are 2 sine x by 2. I write them separately. There are also 2x. I also write them separately. Divide by 2, divide by 2, multiplied by 4. So it is sine 0 by 0, 1. This is also sine 0 by 0, 1. These two negative sign will make it positive, and your answer is going to be half, 2 by 4. Got it? So this is a very important question of this form of the limit. Got it? That is ln secant x upon x square. So better if you can remember this result. Now, another form of the limit is limit x approaches to 0, a to the power x minus 1 upon x is what? Ln a. Log a base e. And limit x approaches to 0, e to the power x minus 1 upon x is what? Very, very, very important. Exponential limit. Am I clear?
Sir, you are clear. Please continue, sir.
Sorry?
Clear.
Is this fine? Now,
Yes, sir. Yes, sir.
let's write a question. Limit x approaches to 0, e to the power 10 square x minus 1 upon sine x into sine 2x. Just give it a try. Take a couple of minutes. Take 1 minute only. Now see, this is equals to limit x approaches to 0, e to the power 10 square x minus 1. If you realize as x approaches to 0, this is going 0. So let us create it in the denominator. So this is also in the numerator. Got it? Now in the denominator, we have sin x. Another sin x, I write 2 sin x cos x. Now this e to the power 0 minus 1 upon 0 will become 1. So what we are left with? Limit x approaches to 0. This 10 square x can be written as sin square x upon cos square x into 2 sin square x into cos x. These two are cancelled. If you place x equals to 0, we get answer as 1 by 2. All right. Now,
Class 9.
another question is limit x approaches to 0, e to the power x minus e cube upon x square minus 9. Now, if you see, this is a 0 by 0 form, isn't it? It can be written as limit x approaches to 0. It can be written as x approaches to 0. Take e cube common. You get e to the power x minus 3 minus 1 upon, sorry, this is not x approaches to 0. This is x approaching to 3. So this will be x minus 3 into x plus 3. Now, as x approaches to 3, this is going 0. This is also going 0. So there is same thing in the numerator as well as denominator and both approaching to 0. So this value goes 1. So answer will be what? Now put x equals to 3. You get e cube upon 3 plus 3, 6. Got it? Next, another question. Limit x approaches to 0, x e to the power x minus 1 upon 1 minus cos x. Okay. So this will be limit x approaches to 0, x e to the power x minus 1 upon 1 minus cos x multiply by x and divide by x. Now this e to the power x minus 1 upon x, 1. So what you are left with, limit x approaches to 0, it is x square upon 1 minus cos x. Now if you remember, I have taught you that limit x approaches to 0, 1 minus cos x upon x square is going to be 1 by 2. So this value is going to be what? 1 upon 1 by 2, that will be 2. Am I clear? Is it fine? Now, a very, very important form, that is 1 to the power infinite. The form suggests limit x approaches to a fx is 1. Limit x approaches to a gx is infinite. Limit x approaches to a fx is 1. Limit x approaches to a gx is infinite. Okay, somebody is asking me to repeat this question once again. So the question is x e ki power cos x minus e ki power x minus 1 upon 1 minus cos x. So what did I do? I multiplied and divided by x. So e to the power x minus 1 upon x is what? 1, which was the just form. And x approaches to 0, it is x square upon 1 minus cos x. And yes, in our previous class, we have done that x approaches to 0, 1 minus cos x by x square is going to be half. So this value is going to be 2. Got it? Now, what I was saying, x approaches to a fx is 1, x approaches to a gx is infinite. Now they're asking you for limit x approaches to a fx to the power gx. Now, isn't it this form 1 to the power infinite? Because x approaches to a fx is getting 1, x approaches to a gx is getting infinite. So this is what? 1 to the power infinite form. All right. So this will be its direct result, you guys remember. e to the power limit x approaches to a fx minus 1 into gx. Got it? E to the limit x approaches to a fx raised to the power gx, which is 1 to the power infinite, is e to the power limit x approaches to a fx minus 1 into gx. Fx minus 1 into gx. Now, there is a proof for it, but I think as of now, we can stay away from the proof. Just remember this form. All right. One more thing, this fx, this limit x approaches to a fx, it should not be exact 1. It should be approaching to 1. It should not be exact 1. If it is exact 1, answer will be 1. Like if I ask you, limit x approaches to 0, greatest integer of x square plus 1 whole to the power 1 by sine x. Got it? Now tell me one thing. As x approaches to 0, x square is also very close to 0, but little more than 0. Got it? That means this value 1 plus x square is little greater than 1. If this value is slightly greater than 1, its greatest integer is going to be exact 1. Its greatest integer is going to be exact 1. And exact 1, this power is what? Approaching to infinite. As x approaches to 0, 1 by sine x is 1 by 0, which is infinite. But here, since the denominator is exact 1, and this is greatest integer function. Since this denominator is exact 1, this value is going to be 1. We will use this form of the limit only if this base is also approaching to 1. It is not exactly. Now see the question here. Limit x approaches to infinite, x square plus 5x plus 3 upon x square plus x plus 2 whole to the power x. Now, first of all, are we aware of this x approaches to infinite? X square plus 5x plus 3 upon x square plus x plus 2. This is limit x approaches to infinite. Take x square common. It is 1 plus 5 by x plus 3 upon x square divided by x square common 1 plus 1 by x plus 2 by x square. Got it? Now, if you see this 5 by x will be what? 0 as x approaches to infinite. 3 by x square 0. 2 by x square 0. 1 by x 0. This x square will cancel. Your answer will be 1 by 1 1. So this is approaching to 1. Got it? So that means this base we are having, this is approaching to 1, and this power we are having is approaching to infinite. So how do we do it? E to the power limit x approaches to infinite fx minus 1. That means x square plus 5x plus 3 upon x square plus x plus 2 minus 1 into x. Fx minus 1 into gx. So this is e to the power limit x approaches to infinite. If I take LCM, I'll get x square plus x plus 2. It is x square plus 5x plus 3 minus of x square plus x plus 2 into x. So this is e to the power limit x approaches to infinite. If you see, these x square will cancel. Got it? So you are left with 4x plus 1 upon x square plus x plus 2 into x. Am I clear? Now it is e to the power limit x approaches to infinite. So this is 4x square plus x upon x square plus x plus 2. Now we have to solve this power in the numerator. So that is e to the power limit x approaches to infinite. Take x square common, you get 4 plus 1 by x. Take x square common, it is 1 plus 1 by x plus 2 by x square. 1 plus 1 by x plus 2 by x square. Now this value is 0, this value is 0, this value is 0 as x approaches to 0. And these two terms cancel, your answer will be e to the power 4. Got it? Your answer will be e to the power 4. All right, we'll try another question. You just see it once. All right. See, the next question is limit x approaches to infinite 2 upon pi tan inverse x whole to the power x. Now we are totally aware while x approaches to infinite, this tan inverse x approaches to pi by 2. So that pi by 2 into 2 upon pi is what? 1. So this is 1 to the power infinite. So this form is 1 to the power infinite. I can write it limit x approaches to infinite, e to the power limit x approaches to infinite, fx minus 1, 2 upon pi tan inverse x minus 1 into x. Am I correct? That is e to the power limit x approaches to infinite. If I take minus 2 upon pi common, I get pi by 2 minus, yes, I get pi by 2 minus tan inverse x into x. That is plus e to the power limit x approaches to infinite. It is minus 2 upon pi. This will be cot inverse x into x. I'll do one thing, replace x by 1 by h. So it will become limit h approaches to 0. Since x is 1 by h, so as x approaches to infinite, h will approach to what? As x approaches to infinite, h will approach to 0. It will become cot inverse 1 by h upon h. And definitely this minus 2 upon pi will follow. So e to the power minus 2 upon pi limit h approaches to 0. So this will become tan inverse h upon h. Got it? And while h approaches to 0, this tan inverse h upon h will be 1. So answer is e to the power minus 2 upon pi. Answer is e to the power minus 2 upon pi. All right. Now take this simple question for your perusal. Proceed with it. You got 2 minutes for this. Answers are also mentioned. And I'll launch a poll. You just try it. Yes. Tell me the correct answer you are getting. Yes. All right. Well, now let's see. Only 8 people replied. See, log P they are asking. First of all, we will solve this. Limit x approaches to 0, 1 plus 10 square root x raised to the power 1 by 2x. Now, as x approaches to 0, 10x will also go to 0. This is 1 to the power infinite. So, answer will be e to the power limit x approaches to 0. Fx minus 1 will be 10 square root x upon 2x. I can write it e to the power limit x approaches to 0. I can write it 10 root x upon root x whole square and extra 1 by 2. Got it? Now x approaches to 0. This tan 0 by 0 will be 1. Your answer will be e to the power 1 by 2. This is your p. They are asking for log p. Log p is log e to the power p, log e to the power 1 by 2. And the answer will be 1 by 2. Got it? All right. Now, let's do another question. Limit x approaches to 0, cos x to the power cot square x. Option I'm giving you, A option, e to the power minus 1 by 2, B option, e to the power 1 by 2, C option, e to the power under root of e. So again under. These are your options. Let's do it using a poll again. Yes. Give me your answers. Now I'm surprised to see somebody has answered D, where D is not any option. Yes, try it quickly. All right, let's do it. So again, this is 1 to the power infinite. Cos 0 is 1, cot 0 is infinite. That is e to the power, limit x approaches to 0, cos x minus 1, and along with it is cot square x, which can be written as e to the power, limit x approaches to 0, take minus common. It is 1 minus cos x upon, make 10 square x in the denominator, divide by x square, multiply by x square. Now if you realize this 1 minus cos x by x square, we already know it is 1 by 2. And this x square upon 10 square x means x upon 10x as x approaches to 0 is also 1. So answer is what? E to the power minus 1 by 2. This is correct answer. Got it? Now, if you remember, we have covered sandwich theorem in the last lecture. Got it? Let's do one question for this. Greatest integer x is always less than x and greater than x minus 1, or even less than or equals to x. Like if we talk about the integer 2, 2 is equal to, greatest integer of 2 is equals to 2. Got it? But if I talk about 3.5, it will lie between 3, 3.5 will lie between, greatest integer of x is 3. That will lie between 2.5 to 3.5. Greatest integer of any number is always less than that number, or sometimes it is equal to that number. Got it? Now, if I divide both sides by x, it will be 1. It will be x minus 1 upon x. Here there is no equality. Now, right side is already 1. So, limit x approaches to infinite, x minus 1 upon x is what? Limit x approaches to infinite, take x common, 1 minus 1 by x upon x. X cancel. Answer is going to be 1. So left side is 1, right side is 1. That means the function which is sandwiched in between, its limiting value is also 1. Got it? Function which is sandwiched in between, its limiting value is also 1. Am I clear? Now this one more question. This question can be done using sandwich theorem. It can also be done even without sandwich theorem. So you just try it once. Options I give you 1 by 2, 1 by 3, 1 by 6, and D option is 2. All right. Try this question and mark your answer in the poll. All right, we are getting a variety of answers. No one is consistent with any particular answer. Well, now let's do it. See, I know this greatest integer of x, it is x minus fractional part of x. So here numerator can be written as limit n approaches to infinite x plus 2x. I will write it x minus fractional part of x, 2x minus fractional part of 2x, and so on, nx minus fractional part of nx. Its answer will be in terms of n, in terms of x. So these are your options. So upon n square. So that is limit n approaches to infinite. Now see, there are terms x plus 2x plus 3x and so on up to nx minus fractional part of x plus fraction part of 2x and so on fraction part of nx upon n square upon n square. Got it? Now if you see this fractional part of x, its maximum value is close to 1, not even 1. Similarly, this fractional part of 2x, again maximum value is approaching 1. Again, fraction part of nx maximum value is approaching 1. So maximum value for the numerator, even if everybody is close to 1, the maximum value for numerator is going to be n. So limit n approaches to infinite. In the first expression, you take x common, it will become n into n plus 1 upon 2, denominator n square minus. Here, maximum value of numerator is approaching n, not even n, upon n square. So this, even if it goes to maximum n, this value will be 1 by n, and value 1 by n means answer will be 0. So what we are left with, limit n approaches to infinite, it is x by 2. Take n also outside, it is 1 plus 1 by n upon n square. This n square cancel. N approaches to infinite with this 1 by n goes 0. Your answer will be x by 2. Answer is x upon 2. Got it? Now I'll tell you about the L hospital rule. This is basically we call LH rule or L'Hopital rule. Hospital is just for writing, it is not the exact pronunciation. All right, LH rule. Now, what is the LH rule? LH rule says if a limit is in the form of limit x approaches to a fx upon gx. If it is in the form of 0 by 0 or infinite upon infinite. If this limit fx upon gx is in the form of 0 by 0 or infinite upon infinite, then this will also be equal to limit x approaches to a f dash x upon g dash x. You just differentiate the numerator and then differentiate the denominator. We get f dash x upon g dash x. Now, if that 0 by 0 or infinite upon infinite form finished, then you get your answer. If we are still getting 0 by 0 or infinite upon infinite, you differentiate it again. f double dash x upon g double dash x. So there will be a time while this form will vanish. This 0 by 0 or infinite upon infinite will vanish, and at that time you will get your answer. Got it? Like a simple question, if I do limit x approaches to 0, sine x upon x. Isn't it 0 by 0 form? So what you do? You do limit x approaches to 0, differentiate the numerator. So derivative of sine x is cos x. Differentiate the denominator, derivative of x is 1. So answer is what? Cos 0. That form vanished. Answer is cos 0, that is 1. Am I clear? See the next question. Limit x approaches to 0. Say you have 10 square x upon e to the power x minus 1 whole square. Now again, this form is 0 by 0. Use L'Hospital rule. That is limit x approaches to 0. 10 square x derivative is 2 tan x into derivative of tan x is secant square x. Denominator में it is twice of e to the power x minus 1 into e to the power x. Now divide by x, multiply by x in the denominator. E to the power x minus 1 upon x, 1. Tan x upon x, 1. Now as this 2 also cancelled. So as x approaches to 0, answer will be sec 0, 1 upon e to the power 0, 1. Answer is. Got it? So in this 0 by 0 form or infinite by infinite form, it is L'Hospital can be applied. But see, applying L'Hospital is not always convenient. Getting my point? This might not be convenient every time. Sometimes it may be lengthy. Sometimes it may be like derivatives are not so simple. So wherever we find it convenient, use L'Hospital. Wherever you don't find it convenient, don't use L'Hospital. Now check this question. The value of sine of ln 1 plus x upon ln of 1 plus sine x. Let's do it a poll. You get 1 minute to answer this question. All right. Well, let's end this and let us solve this. So the question is simple. As x approaches to 0, sine of ln 1, sine 0, 0 upon ln 1, 0. So the question is limit x approaches to 0, sine of ln of 1 plus x divided by ln of 1 plus sin x. If you realize as x approaches to 0, this quantity is approaching to 0. So if this quantity is approaching to 0, multiply and divide by this. And by doing this will become sine 0 by 0. Answer is 1. Got it? Now for this, let us divide by sine x, multiply by sine x in the denominator. This is again ln 1 plus 0 by 0, 1. For this, divide by x, multiply by x. ln 1 plus 0 by 0, ln 1 plus x upon x as x approaches to 0, again 1. And this sin x upon x, sin 0 by 0, again 1. So answer is 1. Got it? This answer is 1. Next question. See, let's do this one. Limit x approaches to a, cos x minus cos a upon cot x minus cot a. Certainly this form is 0 upon 0. So the best way to approach for this question is use L'Hospital rule. Derivative of cos x is minus sin x and derivative of cos a is 0 because cos a is constant upon cot x. Derivative of cot x is minus of cosecant square x and that cot a derivative is again 0. This minus minus goes plus, so it became limit x approaches to a sine cube x. And you just place the value of a because every indeterminate form has gone vanished. So form vanished, your answer is sine cube a. That's it. Got it? So this is another very simple and good question. Value of k they are asking for. See, limit x approaches to 0. In the numerator, if I see, it is log 3 plus x minus log 3 minus x. Do one thing, take 3 common. You get log 3 plus log 1 plus x upon 3 minus. It will be log 3 minus log 1 minus x upon 3 whole divided by x it is. Now this log 3 cancel. That is limit x approaches to 0. Let's split it. Log 1 plus x upon 3 minus log 1 minus x upon 3 divided by x. Got it? Now multiply by 3, divide by 3, multiply by minus 3, divide by minus 3. Log 1 plus 0 by 0, 1. Log 1 plus 0 by 0, 1. Answer became 1 by 3 plus 1 by 3, that is 2 upon 3. All right, let's do one more question. F of a is 3, f dash a is minus 2. G of a is minus 1, g dash a is 4. They are asking for limit x approaches to a, gx fa minus fx ga upon x minus a. See, as of now, this form is 0 by 0. So L'Hospital is the most convenient form because they are also providing the values of f dash a, g dash a, ga. So use L'Hospital. Limit x approaches to a. See, f of a constant, derivative of gx is g dash x minus ga constant, derivative of fx is f dash x and derivative of denominator is going to be 1. Now put the value of x as a. It will be fa g dash a minus ga into f dash a. So fa is 3, g dash a is 4, minus ga is minus 1 and f dash a is minus 2. So your answer is 12 minus 2, that is 10 is the correct answer. Simple application of LH rule. All right. So this was all for the session today. And I hope I have been able to make you understand everything about the limit of a function. So in our next class, we'll continue with the continuity of a function and then differentiability. All right. In the meantime, thank you so much. It was great session. Thank you.